quotient of two functions, the basic part. And so we're given two functions, we're taking its quotient, we're dividing them. And the order of division is important, as we will see. So let's go ahead and work through this one. We will take the g function divided by f, and another way to write this at the point -4 is to rewrite it as g -4 divided by f of -4. That's really what we're doing. So we take the g function, and we're going to plug in -4 everywhere we see an x. So that gives us -4 minus 2 times -4 minus 5. The denominator, we're going to put -4 into the f function. So down here, we get -4 minus 1. Put a parenthesis around this, maybe it makes it look better. So work within the parentheses for -6 and -2. When you combine that, that will give us a negative. Since the signs are the same, we just add the numbers, and they're both negative. We got more negative. -5 and -4, again, signs are the same, so we add them. That's going to be -9. The denominators are both negative, so we're adding them. 4 plus 1 is 5, and it's negative because they're both negative. Negative times a negative in the top gives us a positive. 6 times 9 is 54 divided by -5. Our end answer is going to be negative. 5 does not go into 54. It doesn't reduce anymore. They do not state anywhere in here about how many decimal places to round this to or accuracy. So what we're going to, and they give us, this is another way to see it, they give us these fractions, so they really want the answer as a fraction. 54 over 5, and it's negative. I could put the negative down here, or I could put it out front. I can't do both. It's only got to be one place. So it could be like that, or you could also come to the front of the fraction and put a negative there, and that's the same result. So that will address the A problem. There's not more than one problem or one answer. That's it. I guess you could put it as a mixed numbers. In algebra, we typically don't like mixed numbers because we write things next to each other. We want them to mean multiplication. Mixed numbers are just not a good thing, although I see a number of systems that have it. We'll see how this ends up. Now, what are the values that are not in the domain of G and F? Again, we've talked a little bit earlier about domain, and the two problems we get with domain is division by 0 or a negative and a square root. We don't have any square roots, so all we have to worry about is what number would cause division by 0. Well, division is only going to be caused by the function f. G has no fraction parts in it, right? So f is in the denominator, so we cannot put a value of x in that would give us 0. So we take this function, x minus 1, and to find where the culprit is, where's the bad point, if this ever equals 0, we're going to be dividing by 0, and that's a problem child. So x minus 1 equals 0, that's going to give us that answer. We add 1 to both sides, and we get that when x equals 1, we would end up with 0, right? Because if we put 1 minus 1, that does equal 0. 0 equals 0, right? So x equals 1 is the problem. That cannot be in the domain of this function. And again, all we really focused on was f. X could really be anything. But because f is in the denominator, it means we have to exclude the point x equals 1. And we just do it like that. That's it.